So, let's go ahead and go through this one, Axel, okay? Alright, so we're finding their critical numbers, setting the given derivative equal to 0. We found them to be 0, 2, and negative 3. And we're doing our test values, right? So, what do we end up with? For that middle one, when we plug in negative 1.
Negative.
Negative, positive, positive, right? We end up with a
Negative.
put in what? Positive 1?
Yes.
Positive, positive,
Positive.
positive. The last one is going to be x equals, I don't know, 5.
Negative B.
Positive, negative, positive, so in total it's what?
Negative.
Good? So, now can we answer the question there? Where is the function increasing? F of x is increasing on what intervals? Good. At union?
With
0 to 2. Because f prime of x is greater than 0. Super easy. F of x is decreasing on what intervals? Negative 3 to 0, union, 2 to infinity. Because the derivative of f of x is less than 0. Beautiful. You guys
I
are
love
awesome.
math.
Got this? 17. Where does the graph have a what? Relative min. Okay, so where would it have a minimum?
Zero.
At 0, right? You can see that the curve is going to go back up, right? So we could say f of x has a minimum, relative minimum at, do they want the coordinate or just the x? Only the x, so they were nice to us this time. So at x equals what? 0, because, what's the justification? Beautiful, so what changes? The derivative changes from negative to? You guys are awesome. You're supposed to say I know.
I
know.
What's your time to do that? They were asking for the y value.
They were asking for the y value at this particular moment in time. You cannot get it because you don't know the original function. You would have to know how to find the antiderivative. So that way we could get that derivative and go back to the original function. Yeah? That process is called integrating. Kind of what they did in the 50s and 60s in school. They integrate. No, I'm just kidding. Okay? Anyways. 18. At what values of x does the graph have a relative what? Max. So looking at our sign line, can we figure that out?
Yes.
We're going to have a max where?
And negative 3.
Negative 3 and then?
2.
2. Beautiful. So f of x has a relative max at x equals negative 3 and x equals 2 because, Vanessa? It is a killer clown. F prime of x, the derivative, changes from positive to negative. Awesome. Practice writing the statements exactly like this so that way on the AP test you're ready to go. Okay? It's a lot of writing on that test. Alright, let's look at 19. It says if f of 4 is equal to negative 1. F of 4, that means a number in the original function, right? What is the equation of the tangent line to the graph of f at 4? What do they want us to find here? What are the two things I need for that? Point of tangency and the slope of the tangent. Right? So what would be my point of tangency? We know the x, right? 4? Do we know the y? What is the y? No way. This is like x and this is y? What? That's awesome. Okay, a lot of kids have trouble understanding that, right? The x is what you're inputting, the y is what is output, right? Got it? Okay, what would be my slope?
4.
How do I figure out the slope? Good job, plug in 4 into the derivative. So we want f prime of 4. Do we have that equation? 4 times 2 minus 4 times 4 plus 3. Órale. 4 times what?
No.
Negative 2 times 7. Oh my god, how am I supposed to multiply without a calculator?
You can't.
You can't?
Get a calculator.
Use the old.
You just give up. Oh, don't.
Yeah,
Is the old way?
Him this?
Well, let's do 7 times 4. What's that? 28. And then if you have two 28s, you have how much? 56, right? So if you don't know how to multiply, at least hopefully 7 times 4, you know. Right? And then you can add another 28. Or you can do 4 times 2 and add 4 times, right? You can draw 14 bolitas and then another 14 bolitas. Yeah? And then add them all up. Clown bolitas, everyone's happy? Alright, negative what? 56.
The kids all the time.
Does that mean they're usually colored?
You remember those days?
What?
Good times, right, in elementary?
With the clown bolitas.
So, what's the equation, guys? Y plus 1 equals times what is the next problem asking us to do, Cesar? What do you want to tell me? That answer, right?
Yeah,
What is it asking us for?
to approximate the value of f at 4.1.
So how can I approximate that if I don't even know the original function?
The way we did.
The way we did it last time? How did we do it last time?
We just put it in.
You find the tangent line.
The slope of the tangent line?
Yeah.
Look at it here?
No,
Oh, the equation. Why would I want to use this?
because it's the equation that's really close to that.
Very good. So this equation, right, the tangent line is really close to the curve, right? Because we're really close to what number?
4.
The 4, which is the point of tangency, right? So I could use that tangent line to make that approximation, right? So let's use it. So we're going to say y plus 1 equals negative 56 times 4.1 minus 4. What's 4.1 minus 4? 0.1 times 56. If I have 56 pennies, how many pennies?
What?
Dimes.
Just kidding. Scratch, scratch.
Drop it out.
56 dimes.
Make sure to take that off, okay?
Yeah. Beep. So 56 dimes. How much money do I have?
56 dimes.
$5.60, right? And then we minus the 1. So same sign we add and keep the sign, so we end up with negative 6.6. Good? Now that's not good enough for the answer. We have to write f of 4.1 is approximately negative 6.6. I can't leave it like this because this isn't telling me f of 4.1. It's telling me that y on the tangent line. Understand? And why is it a good approximation? We already said it, but let's say it again. The tangent line is very close to the curve, therefore points on the tangent line would be good approximates for points on the curve. You understand? Cool? Alright, let's try another one. So let's look at another problem that is written or presented a little bit differently, but still asking the same question. Alright, that's what we're showing you. Different representations, different ways that they come out on the AP test, and let's see how you react to it. The one with the table on. Okay?
Is backwards.
Yes, we go backwards here.
That looks good.
I feel really bad. Anyways, let's keep going. We gotta put on a good show for you, right?
Yes.
Alright, so here we go. The table of values below represents the value on the graph of the what?
Derivative.
Derivative. So what are they giving us?
The derivative.
The derivative of a polynomial function. Okay? So that means it is always continuous, it is never undefined, and the domain should be all real numbers. Okay? The zeros indicated in the table are only zeros of the graph of the derivative. Use the table to answer these questions. So if they're giving me a derivative, what is it that I could possibly come up with to help me answer these questions about increasing, decreasing, maximums, and minimums?
A science line.
A sines line, right? So let's make a sines line for this guy. And what do I need to make the sine line? Critical numbers, good job, Caitlin, okay? So critical numbers are where the derivative equals to 0. So can you tell me where the derivative is equal to 0?
-2.
At -2 and at 7. The table is listing the derivatives, right?
Yes.
Alright, so right here we're going to put it on the sign line, -2 and what? 7. Okay. So do I have a function to plug in numbers into?
No.
No, but I have a table that tells me the signs, right? So what are the signs of the derivatives, Aeneas, on the left side of -2? Yep. Negative? No.
Oh, positive.
Positive, you were looking at the x's, right?
Yeah.
So positive, so it's increasing. How about in between these two? Negative. How about beyond 7? Negative as well. So if they ever give you information about a derivative, make a sign line and it'll make answering any of these questions that much easier. Okay? So let's answer them really quickly, and you can write in the answers. I'm just gonna say them all. Where is it increasing? Negative infinity to -2 because derivative is greater than 0. Where is it decreasing? -2 to 7 union positive infinity, right? Why can't I just say from here all the way over there?
Because you don't know what
No, because at 7, it's what?
Oh, it's
0. At 7, it's not negative, it's 0, right? Okay, so be careful, all right? You gotta split up the inner. Got it? And again, that one is because h prime of x is what? Less than 0. Good job, buddy. All right? Where do I have a maximum? At -2. I can see it, right? The curve is increasing and then decreasing, so I have a max at -2. Because the derivative is changing from positive to negative. Where do I have a relative min? You don't have one?
No.
Why not? Because the derivative does not change from what? Negative to positive, so make sure you write that. Huh? Yeah, so you say h of x does not have a relative minimum because h prime of x does not change from negative to what? Positive. You're just providing the justification as to why you know it does not have one. Too easy? Everything becomes easy when we have our what?
Science.
Sign line, okay? So when you can make one, make one. Alright, 13. If h of 3 is equal to 2, what is the equation of the tan line at x equals 3, and what is the equation of the normal line at x equals 3? So they want the two equations. So let's find the tangent line one, and then once we know that one, we can get the normal one, right? So again, we need our point, and we need our slope. So what will be my point of tangency?
3 and 2.
3, 2, beautiful. What will be my slope of the tangent line?
Negative.
At 3. Negative 3? How did you get that? The table, right? The table is giving me slopes. So I go to 3 and it tells me the slope is what? Negative 3. With me, Caitlin? So now I can write my equation. Y minus 2 equals negative 3 times x minus 3. Easy? And they want the normal line, right? So what's my normal line? Y minus 2 equals 1/3 times x minus 3. Is it perpendicular to the tangent line?
Mm-hmm.
Yes. So if I ask you, give me the equation of the line that is perpendicular to the tangent line, you're not going to freak out, right?
No.
You're going to know that that means the normal line. Good? Alright, what does 14 want? The tangent line approximation of this particular value. Alright, so let's use the tangent line to approximate. So we're going to say y minus 2 equals negative 3 times 3.1 minus 3. What do we get there? 0.1 times 3. 10 cents times 3. How many cents do we have?